Hello everyone, welcome to statistics class. If you have not subscribed yet to my channel, please subscribe, press bell icon and press all button so that you can get instant notifications of more videos. Let's start with the first main, that is choose the correct answers, what we usually call multiple choice questions. In that the first question goes like this: expected number of years a newborn baby would live is called as, first option expectation of life, second option longevity, third option survival ratio, and the last option is mortality ratio. Students, this question is coming from Vital Statistics chapter. In that life table concepts, this concept arises. In that we know expectation of life, EX, which is TX divided by LX. Once when we know this age X equal to 0, that means newborn baby, how many years they would live is called as longevity. So the correct answer is longevity. Next question. Theoretically, which among the following averages is the best average for the construction of index numbers? First option geometric mean, second option arithmetic mean, third option weighted arithmetic mean, the last option is harmonic mean. Students, this question is from index number chapter, and we know index numbers are in terms of rates and ratios. Once when rates and ratios are there, the best average is certainly geometric mean. So the correct answer is geometric mean. Next question. The relation between mean and variance of binomial distribution is, first option mean is greater than variance, second option mean is less than variance, third option mean is equal to variance, the last one is all A, B and C are correct. We know this question is from theoretical distribution chapter. In that, in binomial distribution, what is the relationship between mean and variance, it is asked. We know mean is NP in binomial distribution and variance is NPQ. Only the presence of Q it matters here. Other than that, both are equal. This Q being probability of failure, which will be lying between 0 to 1. When we multiply any value from 0 to 1, certainly it will get reduced. That's why NP is greater value as compared to NPQ. So mean is greater than the variance is the expected answer here. So option A is the correct answer. Next question. The statistical constant of a population is called as, first one statistic, second one test statistic, third one parameter, and the last one is parameter space. This question is from statistical inference chapter. Here it is a statistical constant of a population. Let us treat this one is population, and from this population we might have taken a number of samples. So what we are worrying here, statistical constant of population. From this population, if we calculate any x bar, sigma square, that means mean, standard deviation, variance, anything of that sort, these will be called as parameters. You know, that's why statistical constant of a population will be called as parameter. By chance, if it is asked here statistical constant of these samples, then it will be called as statistic. So here for the given question, the answer goes as parameter. Next question. In an LPP, If the value of z increases indefinitely, then it is called as first option, no solution. Second option, unique solution. The third option is multiple solutions. And the last one is given as unbounded solution. So here it is given, in an LPP, value of z increases indefinitely. That means, say this is the drawn LPP, 2 or 3, whatsoever may be the constraints. Here z is increasing indefinitely, it seems. That means for this constraint also it may be more than, and this constraint also it is more than. This is what is the feasible region wherein z is increasing indefinitely. So once when it is increasing indefinitely, is it not, it is an unbounded solution? Yes, that is the reason the answer goes as unbounded. Next question. We shall go for match the following now. So you can read these and be ready to answer and match properly with the given options. Hope you are ready with the answers, students. We shall see how they can be matched. Answers for match the following. First one, it was given fecundity, which is the capacity of women to bear children. It is from vital statistics. The next one was given as 100. Right hand side, value of the index number at base year was given. We know value of the index number for base year is always 100. So these two can be matched. Next, SD and variance are equal. Standard deviation and variance are equal, it is given. Not mean and variance are equal. If mean and variance are equal, then we would have written it to be Poisson distribution. Now standard deviation and variance are equal means it is standard normal distribution. That's why these two will match with this sense. That's why we have matched them. Next, 0 was given towards the left hand side, and one among the options in right hand side was mean of t distribution. We know, students, already mean of the t distribution is always as 0. That's why these two can be matched. Next, the last one which is remaining is shortage cost. Shortage cost is nothing but inability to meet the demand. In the sense, we are not able to meet the demand which is demanded. That's why we are not able to meet the demand. That means not able, that is what is given here as inability to meet the demand. So in that particular sense, shortage cost can be dealt with inability to meet the demand. Next, we shall go for fill in the blanks. First question goes like this. Dash index number satisfies TRT as well as FRT. You have to search for a index number which will satisfy both TRT and FRT. Only one index number which will satisfy both TRT as well as FRT is Fisher's index number. So the answer is Fisher's index number. Next question. For P is equal to dash, binomial distribution is symmetrical. We know, students, in binomial distribution for p is equal to 0.5 or half, the distribution is symmetrical. So the answer is 0.5 or half. If it is p is equal to 0.5 or half, then the binomial distribution is symmetrical. By chance, p is less than 0.5, then it is positively skewed distribution. Then p, if it is greater than 0.5, it is negatively skewed distribution. Symmetrical can be referred to as non-skewed also. That means there is no skewness. Okay, let's go for the next question. Standard deviation of the dash is called as standard error. This is based on standard error definition. You can recall standard deviation of the dash is called as standard error. So standard deviation of the sampling distribution is actually called as standard error. That's why the answer is sampling distribution. Next question. The quality characteristic which does not conform to specifications is called as dash. This question is from statistical quality control. For any production, 3 stages will be there. First one is specification, then the production, and after that the inspection. So whatever the specifications we have specified, according to that whether the production is done or not has to be checked. Once when we have checked, if it is not conforming to the specifications, what will it be called? That is what is the question. So it will be called as defect. So the answer is defect. Next question. In dash solution, the TP, transportation problem, number of positive allocations and m plus n minus 1 are equal. What is that solution of TP will be called, in which positive allocations as well as m plus 1 are equal, it is being asked. So the answer for this is non-degenerate solution, because for non-degenerate solution, positive allocations as well as m plus n minus 1 will be equal. So the answer here is non-degenerate solution. If by chance these positive allocations are less than m plus n minus 1, then it will be called as only degenerate solution.